Okay, so next we're going to look at some graphs, and we're going to say, okay, does this graph represent a function? And to do that, we can use what's called the vertical line test. All right, and the vertical line test is basically saying, if I can pass a vertical line through my graph and it intersects it more than one place, it's not a function. If I can draw all the vertical lines possible through the graph, and it never intersects the graph in any more than one spot, then it is a function. So we look at this one, for instance, and we say, I can draw a vertical line, a number of them, right, that intersect this graph in more than one spot. So this is not a function. Not a function. Why is that? Because whatever this particular x value is has two different outputs. So we have x values that have two different y values. So that's not a function, right? Because a function for each x value, you have only one y value, one output. All right, so here we look at this and we say, okay, I can draw vertical line, vertical line, vertical line, vertical line, vertical line. How many places is each one of these intersecting my graph? And we're going to say only one time. Now this one does have what's called a vertical asymptote, so it's trying to go vertical, but it's never going to actually get vertical, so this one is fine. This one, yes, it's a function. So each x value has one y value. Okay, let's see what we got next. We've got this one. So, we think about our lines here, or something close to vertical line, passes through ones, passes through ones. The only question, really, is this vertical line, right? But this point, we remember, this point is included, this endpoint is included, this endpoint is not included. So even that vertical line only passed through the graph one time. So this one is a yes. Okay. And then we have one more. This one, is it a vertical? Does it pass the vertical line test? No, right? I can draw any number of vertical lines here that will pass through the graph more than one time. All right, so this is a pretty simple test. If there's holes in your graph or jumps, discontinuities, that's really the only time you have to think real hard about it. Okay, so the equations, determining an equation if it's a function is a little bit harder. So we can look at this, and really what we're looking for is, can I rearrange this equation to solve for y? Okay, great. I'm going to add 4x squared to both sides, right? And so if I plug in any number for x here, run it through the formula, square the number, times by 4, add 16, we're only getting out one value of y, okay? So only one y value for each x value. So yes. Yes, it's a function. All right, so this one down here, the x squared plus y squared equals 16, we're going to do the same thing. We're going to say, hey, y squared is 16 minus x squared. And you say, okay, great, but I'm solving for y. I need a square root, right? So if I square root y squared, I'm going to get y. If I square root 16 minus x squared, I'm going to get square root of 16 minus x squared, because it's not a perfect square. And at that point, you're like, oh, well, sure, yeah, plug in a number for x. I'll get out a number for y, right? But I'm going to ask you this. if I take the square root of 4, what is that? And hopefully you think about it, you don't think about it too hard, and you're just like, oh, it's 2. And then, is that the only number? Is that the only number that I can square to get 4? No, right? Because I can square -2. So when you take a square root, you've got to remember that there's really 2 answers here. That's why we have plus or minus in the quadratic formula, right? So here, if I plug in a particular value for x, I'm actually have 2 values of y, the positive value and the negative value. So one value of x is outputting 2 values of y, so this is not a function. Okay, so one value of x outputs 2 values of y, and it's the plus and the minus options. Okay, so that's a good place to pause before we go on to talk about function notation.